So let's start this section discussing the Microsoft Business Intelligence Stack. What is the Microsoft Business Intelligence Stack? The first object that we'll be talking about is the Relational Database Engine. In this enterprise stack, OLTP, or Online Transactional Processing Databases, are stored. When those are converted through ETL to a dimensional model, then that dimensional model is in a relational database in the service for the relational engine. Other data source connections are available in analysis services, such as text files and other database engines excluding SQL Server. Integration services, or SSAS, is the ETL tool. ETL stands for Extraction, Transform, and Loading, and some people even say ELT nowadays for extraction, loading, and then transforming. This development environment is where objects are used to extract the data from an OLTP system or database, transform it to the data warehouse format, and then finally import it into the data mart, which includes fact and dimension tables, as you learn in the dimensional modeling section. This class is going to concentrate on analysis services, which has an engine and creates databases. Here we can store a single source of record for the data with calculations and attributes for end user of the business intelligence environment. By having this single source of data, reports from various client tools will be more accurate, and those calculations won't have to be stored in the reporting tools. Since SQL Server 2012, there have been two options now for the analysis services databases. These are the multidimensional cube since SQL Server 7.0 and the tabular module since 2012. Business intelligence reporting tools in the Microsoft Business Intelligence Stack include reporting services and Excel. These tools, or reporting tools, can connect and report the data from the analysis services databases. SharePoint is also included in the MSBI reporting environment. This helps with the collaboration of reports. Performance Point and PowerView are some of the newer reporting options in SharePoint, and these provide more enterprise-level dashboard and scorecard reporting. So let's talk about Analysis Services 2014. There are two types of analysis services databases since version 2012. These are the multidimensional cubes, which has been inside of SQL Server since around version 7.0. This version of analysis services is referred to as Online Analytical Processing Databases, or OLAP. The tabular module was created when in-memory applications started to catch on in the data warehouse world. This in-memory analysis of data came from the Vertipack engine released with Power Pivot in Excel. Microsoft created an enterprise server-level version of this in-memory column store database in release 2012 of SQL Server. So, why do we use analysis services? Analysis services provides a development environment through a data source viewer to relate data from multiple sources. Though a dimensional model works best for analysis services databases, data can be retrieved from relational database engines like SQL, Oracle, or DB2. Even text files such as comma-separated variable and flat files work just as well as other data sources. Because the calculations are in the analysis services database, the results or aggregations are retrieved much faster than computing the results with T-SQL or report writer code. It also centralizes the calculation logic in one place for all reports to use and is much easier to test or QA in one environment. Instead of having a report writer create the calculations in multiple reports, Analysis Services provides the single source for storing the business intelligence that reporting tools might access. This not only reduces the probabilities of report using different calculations, but it also enables this single source for measures. Report development time is going to be greatly reduced because of this single source of record. Slicing and dicing is a new business intelligence terminology that came along with Analysis Services database. This is used to give the end user the ability to use different row and column attributes in a report or client tool like Excel. Excel's Power Pivot is a great example in showing the power of slicing and dicing, which we will see a little bit later. A user might get to the point in a report where he or she wants a different business entity to drill through. Instead of creating a new report, because of Analysis Services, it will provide the dimensions and the attributes along with hierarchies to slice and dice. Online Transactional Database Systems, or OLTP systems, the stress is reduced from those systems when the company moves to a data warehouse system. The reads for reporting come from the data warehouse rather than the transactional system. The transactional system, or OLTP, is designed for fast inserts, updates, and deletes. It's not created good for reporting, especially when more and more access is requested. Users and system administrators will experience a significant reduction of server resources on the OLTP system once the reporting is moved to a data warehouse and implemented through a dimensional model. Analysis Services was created and designed to query dimensional model data marts, period. Data warehouse solutions using dimensional model have been around for 20+ years in enterprises. If you know dimensional modeling, flowing through the creation of a multidimensional cube or tabular module will be intuitive. So, what's involved with building an Analysis Services database? To build an Analysis Services database, you need a data source to connect to the dimension and fact tables. These tables need to have a common key to relate the rows. The fact table will contain the measures, which we are aggregating, while the dimension tables will contain the attributes that you will be slicing and dicing the measures by. In a dimensional model, surrogate keys are the most often used to relate a dimension to a fact table, not the business key, which is from the OLTP system. The multidimensional cube designer uses the Universal Dimensional Model, or UDM, while the tabular model is expressed by a new term, BISM, the Business Intelligence Semantic Model. The Universal Dimensional Model, or Business Intelligence Semantic Model, have the exact same purpose: store the data sources and relationships in one central place. Here is the data source view from the multidimensional cube. The data source stores the connection string, while the data source view, which you are looking at, stores the tables and their relationships. Here, you can see a snowflake schema for the product, category, and subcategory tables, while the date dimension is being used as a role-playing dimension because it has the relationships to the fact table through the order, due, and ship dates. Here is the same view, but from the tabular module. We have the same tables and relationships with the same snowflake schema and the same role-playing dimension as the multidimensional model. A dimensional model consists of fact and dimension tables. The fact table contains the measures, like sales amount and order quantity. The dimension table contains attribute the user would like to slice and dice measures by. The sales territory, for instance, has a natural hierarchy of group, county, and region. The date dimension contains year, quarter, month hierarchy, while the customer dimension displays demographics like yearly income, gender, or total children. The relationships are usually through the surrogate keys between the fact and dimension tables. A term often heard is star schema, and sometimes snowflake schema. Dimensional modeling can be shown as two types of schema, the star and the snowflake schema. The star schema's objective is to not have a dimensional table related to another dimensional table. Basically, all dimensional tables are related to one or more fact tables, like this example. The snowflake schema has dimension tables that are related to the fact table in a data mart, but some have relationships through one or more other dimension tables. The product dimension in this example has a relationship to subcategory, and then you can see the subcategory table has a relationship to category. This is what defines a snowflake visually. Experts suggest using a star schema over a snowflake schema for processing cube performance, but sometimes a snowflake is the only option available to you. Let's compare the product dimension in the two models to see the difference. The star schema has category and subcategory columns in the product table. In a snowflake schema, the category and subcategory columns are in their own dimension, with relationships based on the surrogate keys to the product dimension. Data warehouse or OLAP schemas are not normalized data structures, as you can see. The purpose of creating a dimensional model is to speed up the retrieval of data for analysis services databases, and this technique, modeling, has been proven to work for over 20 years. Before we move on to using analysis services to create a database, let's look at the Microsoft Business Intelligence future. Everything you have learned in this session carries over to the future of Microsoft Business Intelligence for the masses. Learning the tabular as well as the dimensional model in multidimensional cubes will help with the transition to self-service BI and cloud-based BI. Some of these features will include Power BI with the Designer and Excel integration with Power Query and Power Maps. These cloud and on-premise options can connect to both analysis services types of databases. Before developing an analysis services database from scratch as the multidimensional cube, we're going to deploy and view a cube from a predefined template. In order to view a cube, we need to deploy the cube through a development tool. This development tool is called SQL Server Data Tools. This is the development environment for SQL Server 2012 and 2014. This replaces BIDS, the Business Intelligence Development Studio you might have heard from in previous versions of SQL Server. Management Studio, or SQL Server Management Studio, will be the tool to use to perform administrative functions on relational as well as analysis services databases. You can also configure security and other items to help with the performance. We are deploying a cube at this time to show results for now. We're going to focus on viewing the cube so you see what your end users have available to you. This gives you an idea on how end users can slice and dice data. Before we do that, we need the AdventureWorks data warehouse as well as the relational database behind it and the analysis services cube to work with it. These sample databases used in this class are the AdventureWorks Data Warehouse database, which can be found for free on CloudPlex and is managed by Microsoft. You need to download the zipped Analysis AdventureWorks Data Warehouse database backup, restore it to a relational database engine, as well as unloading the zipped up code for the tabular and multidimensional database deployments. There are 2012 versions of these files as well as 2014, and they even provide a README file which can assist in this process. When you go to that website, there will be a lot of listed downloads. be sure to pick the DW 2014 database and the 2014 zipped up tabular and multidimensional models for their code. Again, reference the README file if you're having problems. In this next slide, we're going to see viewing a cube in Excel, which you'll see throughout the demos of using SQL Server data tools. In this slide, you can see the sales amount from the Sales Summary Measure group in the upper right, which has been selected to slice by calendar year hierarchy on the rows and product category on the columns. We can also use a report filter in a pivot table along with other Excel features to enhance this report. There's even a pivot chart type option, which is another feature of Excel to help you create dashboards and reports in Excel.